Hello, and we are rambling. We are rambling yet again, rambling about May 2022, paper 1 from the department, question 3.2. The first two terms of a geometric sequence are minus t squared minus 6t minus 9 and t cubed plus 9t squared plus 27t plus 27 divided by 2. Very weird looking terms, if I have to say so myself. Determine the values of t for which the sequence will converge. Okay, so this is definitely one of those questions where I think it's easy to look at it and be like, what on earth? Where do I begin? What do I do? And okay, I already kind of have a sense of how I want to approach it, but I want to take the time to also just spotlight one of my most favorite things, one of my most favorite tools in the world, right? For situations like these where you're not sure how to construct the equation that needs to be solved. So what I like to do in a situation like that, where it's like, okay, what is mathematically, what is the question? What is the question? I see the English question, but what is the maths question here? So I will kind of play a game with myself where I say, fine, I don't know where to begin, but maybe let me just guess, right? Good old trial and error. But the thing with trial and error is the ambition of your trial and error shouldn't be to try and get the right answer. It should be to try and see it should be trying to see how you evaluate your answer, because how you evaluate your answer is the equation that you are trying to solve. That is where the equation lies. So what do I mean? Say, for example, I were to say, my guess is t is equal to 0, right? There's no dividing by t, so t can be 0. So then that would mean my first term, which is given by this guy, is going to be 0 squared, minus 0 squared minus 6 times 0 minus 9. So the first term disappears, the second term disappears, we're just left with minus 9. And then secondly, we have t cubed plus 9t squared plus 27t plus 27. Oh, okay, divided by 2. So again, disappears, we're just left with 27 over 2. Okay, so now if I was told that I have a geometric sequence and it begins like this, minus 27, minus 9, 27 over 2, and so it goes. I'm told it's geometric. How would I know whether it converges or not? I would have to look at the common ratio, right? And see whether that common ratio is between -1 and 1. So I would find the r, which is 27 over 2 divided by -9. Yeah, in my previous videos I was in the mood for mental maths, but now my 30-year-old brain is like, nope, I don't want to do it. So calculator is our friend. So this would be minus 3 over 2 is the common ratio of this geometric sequence, minus 1.5. So this wouldn't work. Our sequence will not converge because this r is the incorrect value. It's not in the right range. So more importantly, this gives us an idea of, okay, what is the equation that we're trying to solve? We are trying to find the values of t such that this guy divided by this guy is going to give us a number that is between -1 and 1, and also not equal to 0, because remember, if it's, yeah, does that count as converging if r is equal to 0? I mean, it converges to 0. In that case, the sequence converges to 0. I think in general, it's not a geometric sequence if your r is equal to 0, right? Like, it can't be. Yeah, because then your common ratio isn't necessarily a 0. What am I saying? Okay, I think r can't be 0, guys. Can someone confirm this? By definition, a geometric sequence, r can't be 0. the same way that r can't be 1 or minus 1. Right? Right? Anyway, the more important thing here before my rabbit hole is we are trying to find the value of t such that this divided by this, the r is going to be between minus 1 and 1. Okay, so let's do this. So the r for this geometric sequence is going to be t cubed plus 9t squared plus 27t plus 27 divided by 2, okay, over or divided by minus t squared minus 6t minus 9. Right, so that is the same as t cubed plus 9t squared plus 27t plus 27 over 2 times 1 over that, okay, which is the same as t cubed plus 9t squared plus 27t plus 27 over 2 times negative t squared minus 6t minus 9. Okay, and the question is, how do we even simplify this? I'm going to do this in 2 ways. Okay, so the first thing that I'm going to do is I'm going to factor out this negative that is just driving me up the wall down here. Okay, so it's just going to be t squared plus 6t plus 9. And then I am not rewriting this again, my goodness. Like, do you care for my sanity, universe, do you? Okay, so that's the first thing that I absolutely needed to do for my own mental health, right? And then the next thing is, well, this looks factorizable. In fact, it factorizes as t plus 3 squared, right? So now that makes me feel like, maybe I can factorize this guy, and he has a factor of t plus 3. He must, so that I can cancel and so that things can look nicer, man. So the way that we can check whether it does indeed have a factor of t plus 3 is we can check what happens to this expression when t is equal to minus 3, right? Because if the expression ends up being 0, then we know that t plus 3 can go into this expression. This is the remainder theorem, yeah? This is what you use when you're dealing with cubic functions and you're trying to figure out the factors of the cubic expression. Same potato. So let's quickly see. Minus 3 cubed plus 9 times minus 3 squared plus 27 times minus 3 plus 27. So 9 times minus 3 squared, that's 81. 27 times minus 3 is minus 81. So these two are going to cancel each other out. Okay, and then similarly, minus 3 cubed is minus 27 plus, why is there a random bracket here, madam? So this is minus 27 plus 27. So these two also cancel out. Ooh, it's looking wonderful. It's looking marvelous. So this does indeed end up being 0. So therefore, t plus 3 is a factor of the numerator. Very nice. Okay. So that means that we have t plus 3 times something gives us the numerator. Okay, so we know that the first term has to be t squared. In order for us to get t times t squared is t cubed. So this has to be t squared. And then we know that the last term must be a 9, so that we get 3 times 9 is equal to 27. Okay. Where it gets interesting is this middle term. This middle term is the one that we're not sure about, right? So there's an AT here that is going to be times by this and by this, and the t squared times the t gives us the t cubed. T squared times 3 contributes to this term, and 9 times t contributes to this term. 9 times 3 gives us that term. At times t gives us part of the quadratic term. At times 3 gives us part of the linear term, right? So we need to figure out what is the coefficient of this guy here in the middle. So let's see. I've kind of hinted at it on my way to explaining what we're doing. So we said, just to go over it again, t times t squared gives us t cubed, right? And then t times at gives us part of the quadratic term. It gives at squared, which is part of this guy. The rest of the quadratic term comes from t squared times 3, right? Maybe it's just, yeah, I'm getting lost. I'm losing myself. So maybe let's just write this out nicely. So we've got t cubed. I'm just going to do it in different colors because let's be spicy. Let's be fruity tooty. I don't even know what's the purpose of doing it in different colors, honestly, other than me just having fun. So we are saying pinky pinky comes from this guy, right? The t times t squared. It just comes from one multiplication, really. Okay, and then t times at gives us a blue term. Okay, t times at is at squared. Okay, 9 times t gives us a green term. Okay, right, so that comes over here. Okay, then the next one we have is 3 times t squared. So that's gonna be, it's gonna form part of that term. So, right, so that is plus 3t squared. And then 3 times at is gonna give us a t, it's gonna give us part of this term. So this is the greeny weenie. Okay, so that is 3at, and then finally we have this multiplication, 3 times 9, which gives us the 27. Okay, cool. Yeah, I don't know why I'm drawing them in boxes, but yeah, just for consistency, I guess. Right, so this is what we're trying to figure out. At squared plus 3t squared must give us 9t squared. So that means the a must be a 6. Okay, so let's do that in pencil. So this is a 6. And then let's see if that works over here. So if we replace this with 6, okay, so 3 times 6 times t will be the same as 18t. And 9t plus 18t does indeed give me the 27t. So my a, my coefficient a over here is indeed a sigis. Okay, right. So we now have that. We have factorized the cubic. And in fact, we can factorize this further because actually, this is the same as this. So we don't even need to factorize the bottom. So this actually, okay, let's be consistent with the colors, girl. So this is t plus 3 times t plus 3 squared. And down here we have minus 2 times t plus 3 squared. So one term at the bottom, one term at the top, we can cancel to our heart's content. So this is going to be minus t plus 3 over 2. Right, we've even forgotten what we were working out. We were working out what is the common ratio of this geometric. I don't like this red. but you know, maybe it is time to change. This green is also just very bright. Blue is the sweet spot. We were trying to work out the ratio, the common ratio of this geometric sequence, where term 1 is this and term 2 is this. So we took this and we divided it by this, okay, to figure out what our R is. And yeah, that has all just been us doing the division. So eventually what we're finding is that the R, the common ratio of this sequence, is minus t plus 3 over 2. Let me quickly, we're not done solving this yet, but I do just quickly want to show you another way that you could have gone about simplifying this expression. So if you hadn't known to factorize, for example, how else could you have gone about this? So what you could do is use long division. Let's see how successfully I can extract this thing so that I don't have to write it again. So I'll just do this on a separate page. So so the thing is, we're trying to figure out, okay, what is this divided by this? Do I want to multiply the minus 2 in? No, honestly, I do not. So I would just keep it separate, right? So this is the same as saying minus a half times this whole spiel. Wow. Okay, so really, yeah, we are twine. What's going? Oh, this is guys. Sometimes technology is too clever for my liking. So to do this division, you can do long division. So let's have a look at how that would work. So this would be t cubed plus 9t squared plus 27t plus 27 divided by t squared plus 6t plus 9. So you first say, okay, how many times does t squared go into t cubed? What do you need to multiply t squared with to get t cubed? In other words, you would have to multiply it with t. So then you kind of write it over here, aligned with the t term. Then you multiply the t with this guy. So that is going to be t cubed plus 6t squared plus 9t. Then we subtract. So that is going to be t cubed minus t cubed is nothing. 9t squared minus 6t squared is going to be 3t squared. And then 27t minus 9t is going to be 18t. Then we bring down the next guy. So this is plus 27, right? So the next question we ask ourselves, we kind of repeat the process. So the process is divide, multiply, subtract, bring down. Divide, multiply, subtract, bring down. Divide, multiply, subtract, bring down. Someone said something like divide, what, daddy, mommy, sister, brother. I don't know. Anyway, so divide. How many times does t squared go into 3t squared? So what do I need to times t squared with to get 3t squared? It goes in there 3 times. Then you multiply. 3 times this expression is going to be 3t squared plus 18t plus 27, right? So that is 3 times t squared, 3 times 6t, 3 times 9, right? Then subtract. Okay, so that gives us nothing. 3t squared minus 3t squared is nothing. 18t minus 18t is nothing. 27 minus 27 is nothing. Right, so you can just put a dot over there. So what does this tell us? This tells us that t cubed plus 9t squared plus, what am I trying to do? Okay, this tells us that, oh, guys, my goodness. Okay, this thing of the eraser going back to what it was doing before is so confusing. I should switch it off. Anyway, so this tells us that this quotient, nice English, nice maths. This quotient, which I'm going to shrink, is equal to t plus 3, or in another way you can phrase it is this expression is equal to this expression times this expression, right? So that's another way that you could have simplified it. So now you would have known that, okay, this is the same as t plus 3, so t plus 3 times minus a half gives me minus t plus 3 over 2, which is what we got here, right? Anyway, so we now know the r of this geometric sequence. We now also want to know for which values of t will the sequence converge. So in other words, when is r between -1 and 1 and also not equal to 0, according to myself. So it's two conditions. Okay, r must not be equal to 0 and r must be between -1 and 1. So let's figure that out. Oh, you're on a new page. When's that? What is the new page doing, guys? Oh, okay. Right. So the first thing is that minus t plus 3 over 2 must not be equal to 0. Okay. So for what values of t would it be equal to 0? That would mean that t plus 3 must not be equal to 0. So t cannot be equal to -3, first and foremost. Right, so now let's figure out this part of the condition. So we are looking for values of t that will satisfy this inequality. Okay, so there's a nice linear inequality, meaning we can just times through by 2, for example, to get rid of this guy. So that will be -2 minus t plus 3 and 2. Okay, then yeah, we should have just times by -2 so that we could also get rid of this guy. It's not too late, we can change our minds, guys. So the only thing to be careful of here is that remember that timesing through by a negative means that our signs switch around, and this would no longer be, oh my gosh, this thing is going to drive me up the wall. So this will -1 times -2 is 2, and 1 times -2 is -2, right? So, and then that minus would be gone, which is fantastic. Yo, my goodness, mama. Eager eraser. Oh, golly wally. Okay, right. And then now to get the t alone, we're just going to -3 on all the sides. So this will be -1, and -2 -3 is -5. So the answer is t can be anything between -1 and -5, just not -3. So the way that we can write that is we'll write it both ways. So in inequality notation, we'll say, yep, t is between, t is greater than -5 but smaller than -1, and t is not equal to -3. Or if you want to write it using interval notation, you'll say that t is an element from -5 but not including -5 up until -3, also not included, union with -3 not included up until -1, also not included. Okay, so this is another way that we can write it. Right, and you know, one of the habits that have really started falling off in my life is checking my answers. Like, not just checking it against the memo, but like checking it, you know, sanity checking it, which is so important in exams. So we said that term 1 is given by minus t squared minus 6t minus 9, and term 2 is given by the cubic guy over 2. So let me just copy the cubic bit from over here. Okay, so let's check. Let's choose a number. Let's choose the number here, minus 2. Minus 2 is between minus 1 and minus 3, right? And actually, one of the answers that we said wouldn't work is minus 1.5, right? That's the one we checked. 0, sorry. The minus 1.5 was the r. The t that wouldn't work is 0. And this answer kind of confirms that, because 0 doesn't fall in this set. So, and that makes sense. When we checked 0, it didn't give us an r that would make the sequence converge. Anyway, so let's try minus 2. So if I say minus 2 squared minus 6 times minus 2 minus 9, my t1 ends up being minus 1. Okay, and then if I generate my t2 using minus 2 as my t, I get plus 9 times minus 2 squared plus 27 times minus 2 plus 27, and then down here I get a 2. So this ends up being a half, the term 2. And to go from this term to this term, that means I times by minus a half, which is indeed between, minus 1 and 1. So it is going to be a converging series. So that does work. And then, if you have time in your exam, you could go and check if you chose a t. This thing is so annoying. If you chose a t that is in this part of the interval, so maybe like minus 4, minus 4.5, if you're feeling daring. If you put it in here and you put it in here, you should get an r that is also between minus 1 and 1, and that would cause the geometric sequence to converge. The geometric series sequence. Anyway, let's see what the memo thinks. So they just have t must be between minus 1 and minus 5. They don't have the t can't be equal to minus 3 restriction, which makes me feel like, did I make it up? Does it not exist? Let's see. Let's just do a quick Google search. Geometric sequence, common ratio value. My Google searching is so dodgy. I need Siyavula. Oh, poor Siyavula, guys. Siyavula will tell me what I need to know. Just bear with me. Bear with me. Yeah, where is that going? Where is that even going, actually? Let's not conclude it. What I want is the definition. Okay, so this restriction doesn't seem to exist, eh? Let me just ask Google straight up. Can a geometric sequence have common ratio 0? Mathematics Stack Exchange says it is clearly mentioned that common ratio cannot be 0. A whole lot of people are passionately saying that it cannot be 0. It can be a positive number or a negative number. Yeah, it seems like 0. 0 is not it. The common ratio must be non-zero. Okay, a whole lot of people are saying the common ratio cannot be 0. So I stand by it. I stand by my restriction. But yeah, clearly you wouldn't have been punished if you didn't state that restriction. Anyway, thanks for tuning in. Thank you for lingering around for this little online debate that's going on. And yeah, catch you another time for another question.